I'm Bruce Banner. I'm the principal investigator of the Mars InSight mission that's going to go to Mars to probe the deep interior of the planet so we can understand how rocky planets form and understand the history and processes that have shaped Mars. We've got one key instrument on the spacecraft, and that's the seismometer. That's what we're going to use to really determine what the interior structure of Mars is, the thickness of the crust, the size of its core, the density and composition of the core. That's our main instrument, and that's really the thing that gives us the most detailed information about the interior of the planet. Our second instrument is the heat flow and physical properties package. It's a heat probe that has a hammering mole that digs down 15 or 16 feet below the surface and measures the change in temperature as you go down those 16 feet, and we can extrapolate that temperature increase all the way down to the center of the planet to understand the heat budget of the planet and the sort of the vigor of the geological engine that is shaping the surface. We also have a weather package that gives us the pressure, the wind, the air temperature, and we have a magnetometer that measures the magnetic field on the planet. One of the cool things about this mission from a spectator standpoint is we're going to do something for the first time, which is use a robotic arm on the spacecraft to pick up instruments off the top of the spacecraft and actually place them on the ground. We have our seismometer that needs to measure ground motion, so it doesn't do much good if it's sitting up here on the deck. So we have an arm that's about 8 feet long that picks up the seismometer, puts it down on the surface, and then we have a shield that looks like an upside down walk that we put over the seismometer to protect it from the wind. And finally, we put our heat flow probe down on the surface so that it can hammer itself down into the subsurface. So that's kind of a cool set of operations that happen remotely on Mars that we'll be able to watch through the eyes of our cameras. What I'm most looking forward to is getting back that seismic data that'll tell us the structure of the inside of Mars. My scientific interest for my whole career is how planets work. I mean, planets are more than just kind of lumps of rock that are spinning around the sun. They're really complex devices, really, that are convecting. They're moving. There's stresses. Mountains are being pushed up. Valleys are being opened up. And all those processes are being driven by the forces inside the planet. And those are the forces that I'm trying to understand, and how those forces have evolved through time and how they may be working on other planets in our solar system, like Venus, like Mercury, or even in planets that are spinning around other stars in the galaxy.
The spacecraft's actually been here at Vandenberg Air Force Base here at Astrotech for about the last 5 weeks. It actually arrived via C-17 on February 28th. And prior to that, it did all of its processing at Lockheed Martin in Littleton, Colorado. Over the course of over the last year, we were doing a series of final integrations of the payloads, doing all the system level tests. We did some landed thermovac. We did EMI, EMC to make sure that everything could communicate together. Got the spacecraft in great shape before shipping it out again to Vandenberg on February 28th. And since it's been here at Astrotech, we actually installed the final flight batteries, did some final flight parameter updates, and of course we loaded the propellant. Just last week we did a final wet spin balance to make sure that the spacecraft was balanced so that it could successfully support launch as well as entry, descent, and landing. We're doing some science on the surface of Mars that we've never done before, looking on the interior of Mars. For me personally, although that's amazing and that's the end goal, entry, descent, and landing. As the EDL manager, the entry, descent, and landing manager, that is really, as we've been quoting it, 7 minutes of terror. It's 7 minutes where everything has to go right. We come in at about 12,500 miles per hour, and at that point we need to slow the spacecraft down as it enters the Martian atmosphere, all the way down to about 5 miles per hour is when it finally touches down. And there's a series of events that has to happen, utilizing the heat shield for the first 3.5 minutes of that to slow the spacecraft down to about 1,200 miles per hour. Parachute comes out, stabilizes it at about 1.65 Mach, stabilizes and also reduces the velocity further until finally we separate from the back shell. It's just the lander all by itself. And for the last 45 seconds, we do a propulsive set of firings of the thrusters to successfully touch down softly at about 5 miles per hour. So for me, that's a really exciting part of the mission. It turns out that the Atlas V 401 space launch vehicle is very capable. The InSight spacecraft is actually a little bit smaller than what the launch vehicle can provide, and so from that perspective, we could either launch from Kennedy Space Center or Vandenberg, and just because of the mere traffic and the number of launches that are going on at Kennedy, this was a great opportunity to come launch from Vandenberg Air Force Base. The launch vehicle supported it. It gave us more opportunities to actually do the launch. It also gave a lot of additional excitement from this side of the part of the country. We've never done an interplanetary launch from Vandenberg Air Force Base before, so this is really exciting for this part of the country and for all the people that are getting really excited about this mission. This is a one-of-a-kind mission. Entry, descent, and landing truly is a challenge, but something that Lockheed Martin has partnered with NASA and JPL over the last 42 years since Viking. We've been a part of that, working closely with NASA, so we're really excited about successfully landing on the surface again.